Welcome back to Around the Museum with Joe and Diane, where we are continuing on our journey and we're going to be discussing flight in this program, both the design of flight and some of its problems for evolution, because according to evolution, how many times did flight have to evolve?
4 times.
4 times, four
Yes.
separate times. And none of these creatures are related to each other, even by secular standards?
No, they're a very long way on your traditional evolutionary tree.
Right, so what are these 4 examples of flight?
Well, birds are the most obvious one.
Of course.
Bats, flying mammals.
So mammals, yeah. Birds,
Insects.
mammals, insects.
Flying insects. And flying reptiles. Now, we don't have flying reptiles now, but we know that they did exist.
And we've got some of the models of them downstairs, which we'll head down to in a little bit. But let's just talk then about flight and the amazing design of flight, because I have a designed flying instrument here, which is a boomerang. And of course, this was designed by humans for flying, and it's made out of wood. And if you pick up a tree and throw it, it doesn't come back, nor does it fly. So what's unique about a boomerang then?
Well, the uniqueness is in the design. This thing is designed, it's aerodynamically designed to fly through the air. Now, this is not a returning boomerang, but it will fly in a controlled manner so that someone who wants to use this was used in hunting, could effectively use this and aim it at whatever it was looking for, or whatever he or she was looking for. And so this is a useful piece of functional design. It's not something that just randomly happened to come out of a tree or be found on the ground. And everyone knows that. I mean, even if it didn't have this pattern on it, even if you just had the wood, everyone would know from the curved shape of this, from the aerodynamic design and the way it behaves when you throw it in the air, this was the product of an intelligent creator.
So effectively you've got something which is like an airplane wing. It's going to be smooth, flat on the bottom, smooth over the top, so that the air passes underneath faster than it passes over the top, which is going to create the lift. And if you have it slightly unbalanced, or you have an airfoil at one end, you're going to end up with it constantly lifting in one direction as it's spinning. So you end up with this classic returning boomerang, although not all boomerangs were returning. Some were designed to throw and be, hit a creature or hunting or whatever. But the one thing's for sure is we know that it's been designed because it now has properties that do not come from the materials that it's made of. The boomerang is made out of wood. The boomerang, you throw it, it flies and it comes back. Those are its properties. And if you throw random wood or sticks, it doesn't come back. So you actually have something which has got properties which do not come from the materials which it's made from, which is your definition of design. When the properties are higher than the original information in the materials, you actually have evidence of design. So there's no disputing that this flying instrument, i.e. the boomerang, has been designed. But what about when we come to flight and we look at things like our beautiful crow here? Or even we've got examples of other flying creatures, the bat and the insects, the beautiful insects as well. So when it comes to this, how can we tell that these have then been designed?
Well, in fact, design is the only way to fly, because like with the boomerang, you have to have the right aerodynamic properties. Now, those do not come from the substance that the wings are made of. For a start, they're made out of different substances in birds, bats, and in insects. The aerodynamic qualities come from the actual shape, from the morphology or the structure, so that in the case of the bird, the wings are feathered and you have a base of bones and muscles, and that makes a distinct structure. With bats, again, it's bones and muscles forming the base of that, but it's stretched skin that forms the flight membrane. And then with insects, you have different substance altogether. Insects have a surface made out of chitin, which is a different sort of substance to the keratin that's made that bird feathers are made of. So it's nothing to do with the substance it's made of, it's all to do with the structure, and the structure has to be right to have the right geometry and the right structure for aerodynamic qualities. Now again, that alone will not make a flying bird or a flying bat, because they have controlled flight, they have flapping flight, so you have to have the right nervous system to control the muscles, and you have to have the right sort of monitoring system. In other words, it needs to be able to sense which way is up in 3 dimensions, which is quite complex.
So a good sort of gyroscope,
internal gyroscopic system, good sight. Bats are not as blind as bats, actually. They actually have quite good vision, and birds have brilliant vision, but certainly in their inner ear structure and in their brains. If someone calls you a bird brain these days, it's no longer an insult, because we've done a lot of research into birds' brains, and they're different to mammal brains, but they're just differently wired, but they are a brilliant piece of computing design.
So it's not just that flight then supposedly evolved 4 different times in 4 different, completely different animal groups, but in these 4 different animal groups you have completely different mechanisms for flying, whether it be feathers, stretched skin, a thin membrane, or your sort of insect scales and membrane that is producing. There's 4 unique ways of then producing flight, all using the same basic physical laws, much as we produce, you know, our helicopter versus an aeroplane. They are both flying machines taking advantage of the same basic physical laws, but applying them in different ways. You've actually got 4 different types of flight mechanisms in 4 different animal groups, and these all supposedly evolve perfectly independently of one another. And that, I think, presents a fairly serious problem for evolution.
Yes, indeed. And we need to remember, for an animal to fly, you only get 1 chance at doing it properly. After all, why would you jump out of a tree or off the side of a cliff unless you knew that you were going to be able to land properly without crashing?
Well, going off the back of that, let's just talk about bats for a second, because we have our fruit bat here, right, and some pretty vicious-looking teeth as well. For you know, uses them to rip bananas to shreds. So was a comment on tooth design. We spoke about that in the dinosaur section, but. When it comes to the bats, bats are supposed to have evolved from a sort of small mouse-like mammal. And when you're dealing with the bat wing, it's membrane, it's skin, which is stretched out, and it's actually, effectively its elongated pinky finger, which is the bone is extremely elongated, and then that membrane of skin is kind of stretched out. Now, your kind of standard concept of evolution is mutations, changes in the DNA, mistakes in the DNA, which slowly over multiple generations add features to your creature. That's your standard idea of evolution. So we're not saying that this is something that just suddenly developed wings overnight, and neither would the evolutionists say that. This has to be slow, gradual changes over many, many, many generations. But then you have this concept of natural selection, and natural selection is then going to select for or against the changes that those mutations produce, okay? So just assume for the moment that mutations are producing new information, right? You're not going to get fully formed bat wings overnight or in 1 generation. It's going to be multiple generations. But you have this natural selection at play, which is going to select for the creatures that are there, and it's going to select against creatures that are disadvantaged by their changes. Now, in what world are you going to be able to get a half mouse, half bat type creature with an elongated pinky finger and some membrane stretched over that's flopping about on the floor but unable to fly? How is that creature going to survive? How is that creature not going to be selected against? So you've got a really big problem if you're trying to argue for this slow, gradual process, and that's something that even Charles Darwin picked up on. He said if it could be shown that you couldn't get these slow, gradual changes and this animal surviving over time. So in order to turn a mouse into a bat, natural selection is going to fight against it.
Yes, it's just not going to work. You imagine a bat-like creature or a mouse-like creature with these sort of long, thin, delicate fingers that have no function because they're not much use for crawling around like a mouse, but they're no use flying either. And the other thing in bat wings, of course, they have actual sensors in them that help control the flight. Now, those are no use until it actually does try to fly. So why would they develop in the first place at all?
And of course, with bats, as you pointed out, they have very good eyesight in reality, right?
Yes.
But they are nocturnal, which means they come out predominantly
Yes.
at dark. So even the best eyesight is going to struggle with, particularly in a very dense place like a jungle where a lot of the big fruit bats are, or places in the dark where your caves and stuff are. So bats, of course, have this brilliant system of creating a visual map of their area, which is, of course, echolocation.
Yes.
So it's in the same kind of concept as sonar, right? It's and it's the same general concept as like radar. Radar uses light, sonar uses sound, echolocation uses sound. You know, it's location by echo, where it sends out these high-pitched peeps, and they bounce off and come back and register in the bat's ear, and it builds up this kind of visual picture of its surroundings. Now, if you have a bat that over a course of, 10, 20, 30 million years has managed to survive for generations of slowly elongating pinky fingers somehow, and it's produced this wing, and it jumps off, and by some miracle it is able to fly. If it doesn't have the echolocation, it's going to smash into the edge of the cave wall and die. So it's not just a production of flight, as in the physical wing and stretched membrane. It has to have everything in place. Its brain, the gyroscope, the echolocation, everything has to be functional in order for it to survive.
Yes, you've got to look at the whole animal, its whole lifestyle. And another interesting thing is, notice in the preserved bat here, it's upside down. Bats roost upside down, which means when they fly into a cave, or some of them will roost in trees, they have to actually flip themselves upside down and grasp hold of their branch with their feet. And that is a really clever piece of acrobatics. And it's only recently that scientists have actually worked out how this works. And we've written about that in our newsletter actually a few years ago. So it's worth checking out. But you're right. You've got to look at the whole creature and its whole lifestyle and the environment that it lives in.
Yeah, and it's the same as well. You've got to think as well as with reproduction. You've got a creature which is roosting upside down. The babies have to be able to cope with that as well. And the mammary glands are located basically in the armpit of the bat, and so the baby's got to be able to get to there to feed and so on. And all of this stuff all has to be working together and fully functioning. And this is just one of the 4 types of flight, right?
Yes, that's right.
And the same goes for all the other variations of flight?
Yes, it's the same with birds. You have to look at the whole bird, not just its wings and its feathers. You have to look at it building a nest. Now, here we have this amazing nest. It's quite extraordinary.
It's remarkable. This is, of course, the African weaver bird nest. And you can see how it's built into the branches of the tree, and it has this kind of entranceway going up to it. It's just remarkable.
Yes, so a bird has to know where it can safely lay its eggs. Now, that can be in all sorts of different places. Not all birds will actually build a nest, but they need to know where they can safely lay their eggs. If they are nest-building birds, they need to be able to have the engineering ability to work out, well, what do I need? What sort of substances do I need to go and find? Construct the nest with this really clever geometry so that it will stay together. How is it going to keep its eggs protected and warm until they hatch out?
Because not all birds have quite this level of sophistication.
No,
when it comes to, pigeons are notoriously
Oh,
awful.
yeah.
One or two twigs and an egg on it, and that'll do, kind of thing. So somewhere down the line, they've lost quite the same element of design.
Some of them just sort of a bit of a scoop of a hole in the ground.
And that's that. But still, the fact that you've got everything functioning all at the same time, and eggs are another classic example of how everything has to work. Because if and you're limited on the size that your eggs can get, because too big and your shell becomes too thick for your creature to hatch out. So again, it's got to be just right. It's got to be incubated at just the right temperature. It's got to be Everything's just got to be fall into place, and you can't get that by step-by-step, slow, gradual changes over millions of years. It just doesn't work.
No, it doesn't. And if we move on to insects, well, they have such an amazing lifestyle or lifespan, seeing that they start out hatching from eggs and then they become a sort of little grub-like crawly creature. But it's built into them that they will undergo a process of metamorphosis, and I remember learning about this when I was young. I was just blown away how amazing this was.
And of course, we classically think of metamorphosis with things like butterflies, right? You know, a caterpillar, worm-like creature turning into a butterfly through its chrysalis, or with a moth with its cocoon. But actually, this is what all insects go through in some way or another. They start out, even like you think your big beetles and your Goliath beetles, they all start out there as grub-like caterpillary things. Caterpillars obviously live on predominantly on leaves. Grubs will often, particularly the beetles, will often live in rotting logs and underneath the ground in vegetation and stuff. But they all go through this metamorphosis process where effectively they turn themselves into a chemical soup, and over just a few weeks, the eventual hatch out will be the adult form of whatever beetle or flying creature or whatever it is.
And you've only got one generation to get that right.
Or otherwise,
it's an extremely complex process. So it has to be built in from the start of the life cycle. You've only got one generation to get it right.
And of course, with insects, you know, we talk about this flight evolving 4 times as it's supposed to. Even within insects, there are different forms of flight. So you think of your butterflies and moth, which have these large sort of membranous wings with the scales on them, which they use to fly, which is a different type of flight if you look at the bees, for instance, which have a set of wings which are always there, and they fly in this kind of, you know, figure of 8 formation. And it's the same with things like dragonflies and whatever. And that's a completely different mechanism to that which the beetles use, where you have a hard case and a set of wings which fold up inside. And when the case opens, these wings literally unfold, and they're not damaged because of their folding and unfolding over time. And they fill with the fluid, and that allows this big chunky beetle with spindly little wings to actually take off in flight. So even within this grouping of animals that we've classified as being invertebrates and then one step further into insects, there are still different forms of flight in it.
Oh yes, and we've only recently been able to work out all the details of insect flight because it depends on creating vortices, in other words, little whirling, swirling, like mini tornadoes almost, that give the insects the lift, because when you look at them, their wings just don't seem to be adequate enough for their body size, particularly things like bees and beetles. But now that we've got the technology with ultra slow motion video capture and supercomputers to analyze all the data. Now notice, you know, we need these brilliant pieces of engineering just to understand how it works, let alone design something that actually does the same thing.
And that's the thing, even our most complex forms of flight, helicopters, aeroplanes, so on, they come nowhere close to the incredible design that you can see in these creatures. And, you know, out of these 4 major groupings, and it's important to realise that those are groupings that we've put on them, right? One of them has gone extinct. Yes. We'll go downstairs and have a look at the flying dinosaurs, as they're often called. But just before we do that, we have fossil examples of bats.
We do.
And we have fossil examples of birds.
Indeed.
And we have fossil examples of insects. And we see no evidence of this flight pattern evolving. In fact, if you go back as far as you can, when it comes to flight has always been possible according to the fossil record, fully developed flight details. An example of which would be this dragonfly here, if you want to hold that, Diane. And this is the point. We find fossils of all of these, and they're all able to fly.
Yes. The fossil dragonflies are all instantly recognised, fully formed dragonflies, no matter how old they are classified in the evolutionary system. The same goes for bats. All of the fossil bats we find are fully formed, flying bats. No one's ever found something that is half mouse and half bat. The oldest classified bats are fully formed bats, even down to their inner ears and things like that, which we can now study now that we have these fine-grained scanning techniques. The same goes for other insects like butterflies, same goes for birds. Yeah. So wherever we find fossil flying creatures, they are fully formed, obviously flying creatures.
And of course we discussed birds a little bit more in the last episode where we looked at feathered dinosaurs and made the point that, the oldest fully formed bird that we find is like Archaeopteryx, and 159 supposed million years ago you have a fully formed bird. And living at the same time as these kinds of creatures at the back here, which is the big pteranodon cast of the skull that we have. So Diane, why don't we head downstairs to some of our big models and we can talk about pteranodons and see where that is. So let's go downstairs now. All right, well, here we are, Diane. Just above us here, you can see this model of this flying creature, which is going to be fairly accurate because, as you saw with that skull, the whole kind of detail is preserved, and we do occasionally find all the veins and the stretched skin mark and everything. So we're dealing with an arm of the creature with its little claws at the top here, and then this vein kind of skin stretched out over the animal. And this is a pterodactyl, which is part of the grouping of dinosaurs known as pterodactyloids. And there were two main groups of flying reptiles, often called flying dinosaurs, but of course by their strictest definition, dinosaurs were not the flying sort, they were the land ones, but they're often called flying dinosaurs. There are two main groups, the pterodactyloids and the rhamphorhynchoids, and there's minor differences between them, but this is perhaps the most well-known form, the pterodactyloids, and this is the pterodactyl. What I always found confusing is that you have a pterodactyl, which is the name of the animal, and it's a pterodactyloid, and you have Rhamphorhynchus, which is an animal, type of animal, and he's part of the rhamphorhynchoids as well. So, but not all pterodactyloids are pterodactyls and not all rhamphorhynchoids. Anyway, regardless of that, it's another example of flight which is supposed to have evolved in reptiles, and so it's another issue for evolution.
Yes, because again, wherever you find these in the fossil record, they are fully formed creatures with these huge wings and with these aerodynamic skulls. You don't find anything that's sort of halfway between land-dwelling dinosaur and flying creature.
And of course now, as far as we are aware, these creatures are extinct. There are some accounts of flying reptilian-like creatures, like the thunderbird, for instance, and a few other accounts. But as far as we're aware, these creatures are now extinct. Now, that's not any help for evolution either.
No, that just means they're dead.
Yeah, they're not evolving into... So they've evolved from nothing, as in we don't have a nice succession of a reptilian-like creature evolving wings and flight. They evolve into nothing, although there's lots of diversity between the rhamphorhynchoids and the pterodactyloids, some of them being very, very much larger, but they don't evolve into anything.
No.
And that's it, they've gone.
They've just come and gone.
All right, well, talking about the size of it then, because this is a fairly small flying creature in the reptilian world. The largest of these, the Quetzalcoatlus, which was the size of a small jet plane, right? Big bird. Would they have been able to fly in our current day atmosphere?
No, and that's been quite a... there's quite a debate as to how this could possibly happen because, well, they certainly existed. We've found their fossils.
Yeah.
But when they've been reconstructed, scientists have looked at that and say, well, aerodynamically, this does not work in our current atmosphere.
So you'd need a denser atmosphere in order to be able to allow them to fly. And interestingly enough, one of the things that we see from the fossil record is evidence that both carbon dioxide and oxygen concentrations were higher in the past. So in our present day atmosphere, it's mostly made up of nitrogen, right?
Yes.
And oxygen makes up only a very small percentage. Carbon dioxide makes up a tiny percentage, fraction of a percentage. And there's good evidence from the fossil record, particularly in things like amber bubbles that have been trapped, as well as the fact that you have a much larger abundance of tropical-like plants would suggest that the carbon dioxide and the oxygen percentages were actually relatively higher in the past. And what this would make would be a denser atmosphere, a warmer tropical atmosphere, and an atmosphere which would be good for these flying creatures.
Oh yes, very much so. And the same goes for flying insects. There are fossil flying insects which are bigger than the ones that we have today, which would have a hard time flying in today's atmosphere. So if the atmosphere was denser, if there was higher pressure and there was more oxygen available, that would make flying a lot easier. Because flying is a very active process, metabolically very demanding. You would need a lot of oxygen to power the flight muscles.
Well, just before we finish, Diane, if you want to come over here, because there's a rather interesting fossil which I'd like to show you. So if you just come over here and point out to the camera what we're looking at. This was donated to us, by the way, by a quarryman who actually found this fossil, and he thought he found a human footprint. So can we see this just up here?
Yes, up here we have a footprint. You can see the toes making an imprint there. So something has come down and landed on this piece of sand.
And of course it's been buried very quickly.
Very quickly, that's right. You can't fossilise a footprint
full of seashells and all sorts. And this is actually a footprint of one of these flying creatures, quite a large one, the pteranodon, that has landed and actually left its imprint. And so it just goes to show this is part of the Jurassic rocks, which are a global phenomena. And so it goes to show again this evidence of Noah's flood and the fact that God told Noah to take all the flying creatures on board the ark as well.
Yes, indeed.
Because they weren't going to survive.
No.
Which means that it probably wasn't a local flood.
No, that's right. Well, the whole idea of a local flood is rather silly, particularly for the flying creatures, because they could easily escape a flood. They just have to take off and fly over the next hill.
So, a great fossil for the museum as well. So if we've written about stuff like the flying reptiles and the issues with climate and stuff, so just remind everybody where they can find out about that.
Well, if you go to our main website, which is easy to remember, creationresearch.net, and that will give you links to our other resources, wonderful resources on our YouTube channel. Go to that. Our archive of news reports, that's science news reports, is kept on a file. It's just called the Creation Fact File. And we also have a question and answer site, Ask John Mackay. Again, that's easy to remember. So start with our main website, creationresearch.net, and you can sign up for our newsletter on that as well.
Great stuff. Well, we'll join you next time for Around the Museum with Joe and Diane, so catch us there. Support creation research through tax-deductible giving in many countries. Find out more at creationresearch.net. Got questions? We've got answers. Check out askjohnmackay.com to see Q&A articles by experts from around the world. See also the creationfactfile.com website for latest evidence news from creation research. Why not visit one of the many creation research museums around the globe? Find out more at creationresearch.net. Watch Creation Research TV, a live 24/7 broadcast of everything creation research. Available for free on our YouTube channel and through Creation Research Live. Be sure to sign up to the Creation Evidence News. Regular updates and news from the world of creation research, science, and the latest evidence for creation. Be sure to join us for Creation Conversations, a weekly live broadcast with the whole creation research team dealing with different topics from creation, evolution, and the Bible.